This is section 7.3, applications of linear programming. That means word problems. All right, so write the constraint below, basically write the inequality. Canoe requires 10 hours of fabrication and a rowboat 7 hours. All right, so we're going to let X be canoes, and it requires 10 hours. We're going to let Y equal our rowboat, and it takes 7 hours to construct those. The fabrication department has at least 113 hours of labor available each week. Let X be the number of canoes and Y be the number of rowboats. So it's 10 hours per canoe plus 7 hours per rowboat. Okay, so here's the hard part, is figuring out what the inequality is. Okay, it says the hours that you use have to be at least 113. So the hours here that you actually use have to be at least 113. So the hours that you use, are they greater than or less than 113? Okay, at least the smallest amount you can use is 113, but you can use more. Okay, so that is the constraint. This is the answer that they are actually looking for. Let's look at our next one. This ended up being a duplicate, so I'm just going to talk you through what we're actually going to use. So just ignore this. All right, so a candidate spends, they spend no more than $7,900 on radio and TV ads or spots. Okay, so we're going to let X equal radio and Y equal TV. The radio spots cost $120, and the TV ads or spots cost $710. So we need to write the constraint, the inequality. They can spend no more than $7,900. All right, so we do 120 times the number of radio ads plus 710 times the number of TV ads or spots. And what is that relationship to $7,900? So what you spend has to be no more than $7,900. So what you spend, is that less than or more than? Okay, it has to be less than, and it says no more than, so that includes 7,900. So that is the constraint, that is the inequality that they are looking for. You just have to be careful with the wording on those. Not actually solving anything, just setting them up. All right, a chainsaw requires 5 hours of assembly, and a wood chipper requires 9 hours. And a maximum of 90 hours of assembly time is available. The profit is $180 on a chainsaw and $210 on a chipper. How many of each should be assembled for maximum profit? So we're going to let X be the chainsaw. Y be the wood chipper. All right. A chainsaw requires 5 hours, and the profit is $180. The wood chipper requires 9 hours of assembly, and I make a profit of 210 hours. Okay. And they have a max of 190 hours that they can use. They want to maximize the profit. Okay. So the profit equation, so Z would be the profit. So it would be 180 X plus 210 Y, because it's $180 for each chainsaw and the profit is $210 for each wood chipper. All right, so we do have some constraints here. Okay. X has to be greater than or equal to 0. How do we have negative chainsaws? And Y has to be greater than or equal to 0. Again, we can't have negative wood chippers. All right, so then the third one we have is 5X plus 9Y. Those are the number of hours. The maximum number of hours they have is 90. I don't know where I got the 190 from. Okay, so the hours that they use has to be less than or equal to 90. They can use 90 hours, but they can't use over 90. So the hours that they actually use have to be less than or equal to 90. Okay, and if you wanted to graph it, this would be X is equal to 0, Y is equal to 0. Since it's greater than, it's everything. I'm just going to shade everything in this quadrant, just like we did on the last section. So we do need to graph this last, or figure out where the corner points are. So let's change this. Let's solve for Y so we can find some points. Didn't give myself much room there. All right, divide out the 9. All right. So let's put that into the calculator. Y equals, let's clear this out. Negative X plus 10. We need to find where, I guess we can graph it. Makes a little triangle. So we do see we have an x-intercept and a y-intercept. So second table. All right, we have 0, 10. And one another 0. Everything has to be positive. So 0, 10. There we go. And 18, 0. So the points are 0, 10, and 18, 0. And that's to graph this one here. So 0, 10, and over 18 up 0. And that is Y is less than. So that's going to be below it, to the left of it. And that's also where X is greater than 0 and Y is greater than 0 overlap. All right. So we have how many corner points? We have 3. One here. Let me change the color quick. Okay, at 0, 10. We have one at 18, 0. We also have one at 0, 0. So we want to maximize the profit, which is this equation here. So if you plug in 0, get 0. Then let's plug in the 0, 10. And then plug in the 18, 0. All right, so this is the max. 18, 0 maximizes the profit. So the profit is maximized when we produce 18 chainsaws and 0 wood chippers. Now you may say, well, we make more of a profit off of a wood chipper. That is true, but you also have to remember it takes a longer period of time to assemble the wood chipper than it does a chainsaw. Okay, so that comes into play. Let's go down and look at the last two. All right, deluxe coffee is to be mixed with regular coffee to make at least 40 pounds of a blended coffee. Okay, I am going to have to find X and Y here. So let's let X be the deluxe regular. Hold on a second. Yep, that's right. X is the deluxe. And then we're going to let Y be the regular. Guess who did not label their variables? And I did this. All right. All right. Deluxe must be mixed with regular. I always put X and Y in order that I find them in the question. Make at least 40 pounds of a blended coffee. Okay, so however many pounds of X plus however many pounds of Y, it must contain, and we need to make at least 40 pounds. So the amount that we make needs to be greater than or equal to 40. The mixture must contain at least 7 pounds of the deluxe. So X has to be greater than or equal to 7. They didn't tell us regular. Okay, so that means the regular coffee has to be greater than or equal to 0. All right. So X equals 7 or greater than 7 is right here. Y is greater than 0 is down here. It's probably hard to see. And then this last one, we'll subtract X. Okay. And when you graph that, that's going to be this line here. You can use your table again. Okay. So this one, the slant one, has to be greater than, so that area is going to be shaded above it. X has to be greater than 7, so that's here. And then Y has to be greater than 0. So this shaded area is where all three overlap. Okay, that's where the shading comes in. All right, so let's find the corner points. Okay, so when I put this in, this is going to cross right here. at 40. Put it into the calculator and then find the point where one of the zeros is. Now, when you graph this one, let's look at this. X has to be 7. Okay, so if you go through the table, or you hit second table, and you find where X is 7, the corresponding Y value is going to be 33. That's this right here. And this point down here is at 40, 0. And then it only has 2 because these, again, keep going. We have to have at least 40 pounds. We can have more than 40 pounds. All right. So what do we want to do here? We want to minimize cost. Okay. So we want to minimize 5x plus 4y because it costs $5 for the deluxe coffee and $4 per pound for the regular. So we want to minimize the cost. So let's plug in. These are our corner points. Let's do the second corner point. All right, so that combination will minimize the cost. We'll use 7 pounds of the deluxe coffee and 33 pounds of the regular coffee. Right. And these are just, the graphing is pulling from 7.3. All right, an auto mechanic, he has shocks and brakes. So let's let X be the shocks and Y be the brakes. All right, it takes 4 hours to replace the shocks and 2 hours to replace the brakes. He works no more than 60 hours a week. Okay. So 4x plus 2y, no more than, so the number of hours he works has to be less than or equal to 60. He routinely completes 3 shock replacements and 8 brake replacements per week. So shocks has to be greater than or equal to 3, and brakes is greater than or equal to 8. If he charges $5.50 for the labor on shocks and $3.50 for the labor on brakes, how many jobs of each type should he complete a week to maximize his income? So we want to maximize, so we want to make the most money. 550x plus 350y. All right, so I'm going to take this top equation here. I'm going to bring it down here just so I can solve for y. Let's move our x first. And then I'm going to divide each 1 by 2. All right. So a little trick here. Okay, X is equal to, or X is greater than 3. That's this. Let me change the color real quick. X is greater than 3 is here. That's where the shading to the right comes from. Y is greater than 8 is here. Oops. Greater than, it's above. And then the one with the slope, the 30 minus 2x. Let's look at this. All right, so first of all, the x was 3 and the y was 8. So this y is 8 and this is x is equal to 3. So when you put this into the calculator, find where x is 3 and then find where y is 8 on the table. And this is what you get. So that's 324 and 11, 8. And then the point where you have the x and the y, that's also a corner point, is 3, 8. Now we're going to maximize z. So we're going to plug each one of these points in. Maximize our profit. And I've already pre-worked these. I am not doing this in my head. 324. All right. So this will maximize the profit when you do 3, was it shocks or breaks? Let's look. Shocks, 3 sets of shocks, and 24 break jobs. And that is it for chapter 7.